Hello, my name is Richard Lobianco from Scottish Carbon Capture and Storage at the University of Edinburgh. I'm very happy to welcome everyone to today's webinar. This is the project's fourth webinar overall. It's the third one in this five-part series we're running this autumn. And today's topic, we're looking at investigation and prospects of CCS technology for climate change mitigation in Greece, West Macedonia. Today's presenters are Dr. Nikolaos Koukouzas from CERT and Dr. Dimitrios Katena from HIRMA. And before I get started, I just want to give a very brief overview for the pilot strategy project for those who might be joining for the first time. Pilot strategy was born from some of the work, building on some of the work from a previous project called Strategy CCUS, also a Horizon 2020 project. It's a 5-year project that started in May 2021 with 16 partners in 7 countries. The project is investigating geological CO2 storage sites in industrial regions in Southern and Eastern Europe to support development of large-scale carbon capture and storage. Detailed studies are being carried out in France, Portugal, and Spain. But the project is also enhancing the knowledge of CO2 storage options in Upper Silesia in Poland, which we had our webinar last week, and in West Macedonia in Greece, which we will be discussing today. So without further ado, I'd like to hand over to Dr. Koukouzas for the first presentation. Dr. Koukouzas, the floor is yours.
Yes, hello everybody. I hope that you can hear me. My name is Nikolaos Koukouzas. I work for Center for Research and Technology, Hellas, which is the main research center in Greece, with the fields in energy, environment, informatics, and transportation. We participate in a pilot strategy project, working together with all partners, as a continuation of a previous project named Strategy CCUS. And we do some work in West Macedonia, as Richard said before. So I'm going to give you an overview of our work until now. So I think I can go now from the beginning, start from the beginning. So you can see my full screen. So the contents of my presentation is, first of all, the climate change. The second is the CO2 storage opportunities and storage capacity. A little bit of information about seismic data, but my colleague can give more information about this. And transportation network and opportunities for CCS in Greece.
Dr. Koukouzas, we can't see your slides just yet. If you want to try sharing them again.
So, sorry, you cannot see my... Yeah.
No, not at the moment. If you want to try screen sharing just again.
Is it okay now?
Nope.
Let me...
There we go. It's coming up just now. Yeah. You can go into... Yes, you can go into presentation mode if you like, and we can see them.
Yeah, okay, sorry for that, but I'll try again. So I'll give the first slide. I don't know if you can see my first slide now.
Yes.
It's about the contents of my presentation, which are the climate change, CO2 storage opportunities and storage capacity, seismic data, transportation network, and opportunities. So what is the general aim of this presentation is to give you something about the implementation of CCUS, carbon capture, utilization and storage technologies in Greece, and related to pilot strategy project. So our part of this project is to investigate the appropriate sites for CO2 storage in West Macedonia in Greece. Why we do that? As we know, we have things related to greenhouse gases, especially CO2, are part of the other climate change factors that are like floods, droughts, wildfires, natural processes, volcanic eruptions, human activities, energy demands for the fossil fuels, and results in crops and food. What we have is the increase of CO2 globally. So here we can see a picture from 2005 up to 2020 and today, but this is not only in global, we have an annual increase in CO2, as you can see with a small fluctuation, but we have CO2 increase rapidly. So let's go to Greece. Why we concentrate our work to CO2 in Greece? Because we have also, even Greece is a small country related to CO2 emissions. We have CO2 emissions, especially in West Macedonia. This is the place where you can see is in the rectangular here. So we have West Macedonia is in the northern part of Greece, very close to Albania on our side, and Fyrom, former Yugoslavia, on the north. Why we have CO2 emissions there? Because all these years we have tremendous lignite production, coal production, and coal power plants emit CO2 every year, million tons of CO2 per year. So as you can see, a part of the West Macedonia area, in Greece we have also Attica, where is the capital city of Greece, Athens, where we have CO2 coming from refineries, cement companies, and steel industry. So that's why we propose to work in West Macedonia, because we have all these CO2 emissions. So the source of CO2 emissions in West Macedonia comes from ETS, buildings, fuel stations, farms, and airports. Here is also a map of Greece with CO2 emissions, as you can see in red color, where we have Ptolemais. Ptolemais is in West Macedonia. And the Meso-Hellenic Trough, which is in Grevena, West Macedonia, more or less the same place. This is the place where we try to find the storage sites for CO2. Ptolemais is the area where we have the CO2 emissions from the power plant. A part of this area, we have also CO2 emissions in Attica, peninsula region, let's say, with CO2 coming, as I told you before, from refining cement, and Thessaloniki. And here we have the other places where we identified for potential storage sites in Greece. So a part of the Meso-Hellenic Trough is Alexandria area and West Thessaloniki, as well as Prinos. Prinos is the place close to Kavala, close to Thasos Island, where there is probably the most recent CCUS news for Greece. Now we're planning, as the Greek government agreed, and get some funding from the European Commission, around 150 million euros to support CO2 storage in the area of Prinos. Here we have the oil deposits, exhausted oil deposits. So there we try to get CO2 in Prinos area. Probably is the most important CCUS project in Greece. So let's go back again to CO2 storage and to West Macedonia area. Here you can see the aquifers in West Macedonia, where there are the power plants. As you can see, SES is the coal power plants in Meliti, which is situated close to Florina, close to the borders with Fyrom, former Yugoslavia Republic. A part of this Meliti power plant that emits over 1 million tons of CO2 per year. We have another, the most recent power plant is in Ptolemaida 5, as you can see, where this power plant will emit around 4 million tons of CO2 per year. It's a new power plant. It's the most recent coal-fired power plant in Greece, of around 650 megawatt. This power plant will be fueled with lignite of this area until 2028. After that, Greece has decided to continue with a shift to gas. Until then, we will have around 4 million tons of CO2 coming from this power plant. I suppose that this can continue in a smaller amount after 2028 with the natural gas power plant. And of course, here we have another coal-fired power plant of around 1,600 megawatt, which is named Agios Dimitrios. And also there is a quicklime plant nearby. As you can see from the area, we have different kind of formations, geological formations. Apart of the alluvial formations, we have carbonate, crystalline rocks, fleece, molasse, neogen formations, ophiolites, plutonic and volcanic rocks. The area that we try to work now is this area called Mesohellenic Trough, which is nearby the CO2 emitters located in Ptolemais, Kozania, Mindo, and Florina area here. So what is the storage capacity in this Mesohellenic Trough area? We have, first of all, Pedalophos. This is the Mesohellenic basin in red color. And in the middle of this Mesohellenic basin, we have Pedalophos formation and Heptachori formation. So this is the two geological formations that we believe that we can have CO2 stored. In Pedalophos formation, we have a lithology consists of conglomerates and turbidic sandstones and shales. The average depth is around 1,500 meters, and the porosity is around 20%, while permeability is 29 MD and capacity around 6 gigatons. The second formation is named Heptachori formation. The lithology here is similar to the previous one, is conglomerates, sandstones, marine turbidic shales with lignite horizon and marine sandstones. Here, the average depth is higher, so that means lower depth of around 2,500 meters, a little bit of lower porosity, 12%, permeability 18 MD, and capacity much higher, around 700 gigatons. So this is the place. I go to give you a little bit about the seismic data, but I believe that my colleague from Herema can give us more information. So I'll go very, very fast. So this is the Herema's actions related to the Mesohellenic Trough with the different stages of the seismic data, of processing of seismic data. Here we have also the area, which is exactly the same play area that I showed you before. And here we have the storage permitting process that according to the national law, we follow the EU CCS directive, and Herema is the licensing authority for CO2 exploration and storage permits in the geological formations of Greece. So let's discuss a little bit now about the transportation network. As I showed to you the map of Greece and the Mesohellenic Trough, what we expect to have to get CO2 from different ports. So again, the same Pedalafo and Deptachori formation in the Mesοχellenic Trough, but CO2 will come from Thessaloniki port, Kavala, and Igoumenitsa ports to be injected in these geological formations. So what we have as an estimation from our side is that I use Dimitrios to Pedalophos. So let's discuss about the CO2 emissions from the power plant. I use Dimitrios to Pedalophos formation, which is here in the Mesοχellenic Trough, is around 50 to 60 kilometers. While from Ptolemais 5 to Ephtachori formation is around 80 to 100 kilometers. So this is the first option for pipeline connection. The second option is the road network. So coming from these power plants to by trucks. The last option is the railway network. But as you can see here, the railway network is not very much advanced in this area in Ptolemais, so it's not connected to the CO2 storage site. So let's see the pros and cons of these transportation network types. So pros for pipelines is that it's suitable for long distances and large volumes. And it's very good for continuous flow. And the cost is low for long run. The cons is that we have high initial cost for construction. But here I have to say that if this can be, let's say, mixed, the construction cost can be smaller when it's connected with another construction like hydrogen. So this is another story. And of course, it requires additional compression stations depending on terrain. For road network, it's good for it's flexible for short distances and small volumes, and can be used temporarily or for pilot projects. What is the cons, which in our case is very important, is limited capacity and expensive over time due to fuel maintenance and driver costs and challenging terrain in maintenance area. Railway, here the pros is that the existing infrastructure in some areas, not in all over the places, and can be used for smaller scale projects and multimodal optional possible. So as I showed you before in the map, there are no emitters and storage sites close to railway lines. And there's a complex logistic, so it requires adaptations of rail routes. So these key factors for pipeline cost estimation are the length of pipeline, the diameter of pipeline, the compression stations, and of course permitting, land acquisition, environmental assessment, and contingency. Here we have an estimated cost for the pipeline. This is a part of this work in the pilot project under deliverable 4.9. So we have, I use Dimitrios Pedalafo, as we said before, 50 to 60 kilometers. The pipeline cost is around 40 to 50 million euros, while in Ptolemais Ephtachori is 80 to 100 meters length kilometer, and the pipeline cost is 68 to 80 million euros. So at the end of the day, with the compression stations of number of 5 to 10, we go to total cost that includes 25% additional cost, 56 to 73 million euros for the first route and 86 to 123 for the second one. So in this, as an overall cost, around 140 to 180 million euros. So this is what we said about transportation. So here you can see the numbers we said before, 142 to 186 million euros for an operation of 20 to 30 years. And for capturing, we estimated around 5 million tons of CO2 with an average 150 to 350 millions of euros. If we add the storage cost, which is 10 to 20 euros per ton, that means 50 million to 100 million euros per year. So you can see more or less the cost for all these three ways: capture, transport, and storage. So where are the opportunities for societal and economic part of this work? So what's the benefit? The benefit is that we create substantial employment opportunities. We support the achievements of the national net zero targets. We secure the competitiveness of Greece's hard-to-abate industries and get considerable EU funding. So from our side, it's very important to continue with this pilot strategy project, taking into consideration all these factors we discussed before. I have to acknowledge our team working in CERT for this project. So it's Dr. Pavlos Tyrologou, Dr. Christos Tergiou, Christina Karatrantou, Giorgos Maraslidis, and Eleonora Manoukian, geologists and mechanical engineers working in these projects for over 2 years. We continue with the project. I'd like to thank you for your attention, and also need to acknowledge the companies and organizations involved and cooperated with us for the benefit of the project. So thank you very much, and we'll be very happy to answer your questions at the end of the day. So, Richard, can I give the floor now to Dimitrios?
Yes, thank you very much, Nikolaos, for your presentation.
Yeah. So I stop my, okay.
I have, okay, is it on, okay, can you hear me now? Okay.
Yes, we can hear you and we can see you in presentation mode.
Yes, thank you. So thank you, Nikos, very nice presentation. Now we will actually present some more specific parts that we have been doing and carrying out since the last almost 2 years. When I started being more working intensively in this project. So here there's a presentation that we have prepared together with my colleagues who are supporting me in this project. So I will not, so the contents, I will start with a few words about, to say a few words about HEREMA as role in the CO2 storage licensing as a CO2 storage licensing authority. We'll continue with a few seismic examples during the seismic data reprocessing, which took place during 23 and 24. We will continue with one slide about techno-economic analysis and the way forward for this in the next year to work that has to be undertaken by HEREMA. So, okay, the general aim is common. What Nikos said about the CCUS technologies and utilization and storage. The aim again is common. We're also focusing in the Mesohellenic Trough, which is located in the West Macedonia, in the northern part of Greece. So a few words about HEREMA is governed, the CO2 storage permitting in Greece is governed by the 2011 ministerial decision, which was transposed to the EU CCS directive into the national law. In September 2020, in April, sorry, 2022, HEREMA was designated as the CO2 storage licensing authority, but not only CO2, hydrogen and other gases, and they're responsible for risk exploration and storage permits in geological formations. Later in September 2022, HEREMA awarded the first exploration permit to Energean for the semi-depleted Prinos oil field, which is located in the northern, offshore northern part of Greece. And in July recently, Earth Energean subsidiary submitted the application for the storage permit, including all the necessary technical studies. In a sense, whatever is required to be included by directive guidance, the directive for the CO2 storage licensing. So it is outlining the injection, monitoring, mitigation plans, as well as the environmental impact assessment study. And parallel, what we have been working is HEREMA is currently working on the comprehensive regulatory framework that is addressing the following issues: the licensing, the data ownership, the capacity allocation, financial support, pricing methodology, as well as the clawback mechanism, which is very important for both state and investors. So parallel to, in addition to our regulatory work, we have started exploring for additional storage capacity. Here in this area, you can see the Mesohellenic Trough. This is the Prinos as well that I mentioned earlier, which the company Earth has just submitted the application for permitting, for the storage permitting. And recently we signed an MOU together with the Hellenic Survey of Geology and Mineral Exploration in order to exchange the know-how and utilize data that they have been undertaken and carried out in the past. And here you can see the basins that we have delineated as potential CO2 storage sites. All these basins, together with HSGME, with the Geological Institution, we're in the short near future, we're gonna start investigating all of these areas in order to develop more CCS projects here in Greece. So we'll move to the seismic data reprocessing in the Mesohellenic Trough, which was undertaken the last and this year. So it took 6 months. That was the duration of the reprocessing. We were working closely with a Polish company, namely Geophysica Turun. So we started from the geometry loading and pre-processing, the noise, velocity analysis, the multiple, and we'll end up with the Kirchhoff pre-stack time migration. All the final projects of these lines have been evaluated by HEREMA's design team. So the processing was carried out with the high international standards in accordance with the processing practices, the geophysical processing practices. And the final pre-STM seismic sections and velocities have been loaded into a state-of-the-art geoscience software we have hosted here at our premises. So this is an example. Here you can see a legacy brood stack. This is actually the initial states where you don't have done any velocity analysis or NMO correction. It's just you know, the starting point. So here you can see these undeclines, and here as well. And here this is unmigrated time section. Still you can see, just you have to spot in the arrows to notice. And then in the next slide you can see the post-up. So all these have been opened up. All these undeclared bow ties, they don't exist anymore. If I can go back, you can see again the processing and how the migration has taken care of all of these reflectors that they are not really true events. Sorry. And this is the final pre-stack time migration with the phase balancing. So it has improved the seismic not only in the shallow part, but also in the deeper part. This is an additional product that the company offer that is very good for stacking improvement. And if you go back and next, you can see the improvement even in this area in the deeper part of the section. So we are gonna look on also in another line. So here you see an unmigrated seismic section. So you see here some sync lines and also this part of the reflectors if you spot the arrows. And then you see this post-stack time migrated seismic section. And then the pre-stack time seismic section. So you don't see anymore some reflectors that they look like to be very coherent and strong. Spot also in this area when we go to the final pre-STM with the phase balancing. So if I go back, then you can see the improvement even the deeper part. So still you can interpret some reflectors and which were not apparent in the previous processing step. Now we will move to the seismic interpretation report, which is in project. So you can see some of the content of the seismic interpretation report, which is the next step after the reprocessing. So and here you can see in this surface the sampling area that CERT has undertaken. Of course, we use some historic data, gravity, magnetic data in order to guide us for having a better and more accurate interpretation, as well as the logs that there have been on the margins of the basin. Now we're gonna move to the CO2 storage injection cost capacities for the development of the CO2 storage in the Mesohellenic Trough. So this is just an this is part also of the deliverable 4.9, which Nikos has mentioned previously. So we assume this is for the seismic survey 70 by 30 kilometers grid, and with an allocated cost and an option for 2 kilometers line spacing. And for in order to inject the 3 megaton per annum, so we have assumed 3 wells with a total cost for 43.2 million. For the storage capacity, we have assumed 90 megatons. This is an assumption with an allocated capex estimated to 300 million tons. And we have considered also the contingency and deflation index exchange rate, what is agreed from the consortium from the pilot strategy. This is what we have considered. And for the OPEX, we have included the social engagement 2% annually, which is actually including the public support and awareness of the CO2 storage and the CCS in general technology, and carrying out surveys and making reports, environmental also safety awareness and reporting, among others. So this is the target that for the 3 MTPA injection for 30 years was assumed with the CO2 price scenario law with 10% discount rate, and we have estimated the NPV of the project to be 991 million euro. And this is considered actually as a concept screening for those people, especially for the engineers, they could understand that for the level 5, this is what it represents. So the way forward is not moving. Okay, so we have the seismic interpretation report. We're still preparing this, which will be delivered, agreed to be delivered in December 2024. Recently, we announced a new tender for the lines, the AO, GREV, the colder actual lines you see on the map, which are coming from the 80s with the dynamite source. That's why you see they're more straight compared to the GRV lines. This is the first dataset with the gray color. And later on, as you can see from our milestone, we will submit the final deliverables together with CERT and their final report around summer 2025. Okay, thank you for listening. So if you have any questions, please go ahead.
Thank you, Dimitris, very much for your questions. Sorry, for your presentation. We're now going to move on to a question. So a reminder that if you prefer to send your questions via text, please do so in the Q&A. What I'll do now is I will enable the microphone for all of the participants. A reminder to please keep your microphone muted. Unless you have a question, please raise your hand. So I'll do that just now. And I'll allow video cameras as well for the attendees. In the meantime, so while we're expecting any questions, I'll take the opportunity to share details of the following webinars that we're having in the series. So we're halfway through. There's 2 more webinars in the series over the next 2 Thursdays, next week and the following week. We're into November, where we're featuring details from France next week, and also we're finishing on Spain the week after. You can find them, and I'm just putting a link in the chat for the events page of the Pilot Strategy website, so you can sign up for those webinars as well. So we'll open the Q&A. Please, if you have any questions, please send them. There's one come through in the Q&A just now. And a couple, in fact. So first question, not particularly addressed to anyone. Has the environmental impact for each option been considered?
Can I think the question is, when you say environmental issues, probably you mean about the different options. You mean the rail, trucks and other things, or this is something that we discuss it now. It's not only, as I told you in the presentation, first priority for Greece now is Prinos, CCS, CCUS. So all concerning environmental issues refers to Prinos possible storage site. So for our case in this Mesohellenic Trough case study, this is something that we need probably discuss at a later stage, I suppose, because we are now at very starting point and research point, let's say, not a commercial stage.
Thank you, Nikolaos. There's a question as well from the same person. Is the utilization of CO2 also envisaged, or storage only?
So I didn't hear the question. Could you please read some?
Are you considering CO2 utilization also, or is it storage only?
Yeah, in this particular project, it's only storage in this pilot project for this Mesohellenic Trough. But there are some options for utilization of CO2 through methanol process. Especially, there are scenarios from CO2 coming from Ptolemais 5 power plant with the utility PPC as an operator. So there are possibilities for methanol production and other also utilization applications. So, but in this particular project, not only storage.
Thank you. Next question says, could you indicate approximately on the seismic at which depth the storage formations would be?
I can, I think Nikos has shown in one slide, he has pointed 2,500 for Pedalophos and for Eptachori 3,000, right?
It's 2,500 and 1,500. Yeah.
1,500, yes, salary, yeah.
And a second question from the same person. What about monitoring solutions across the CCS chain? I guess they have been taken into consideration?
Yes, this is taking into consideration. You mean chain? You mean utilization and storage? You mean the whole chain, CCS, I suppose. Yeah, it's not very clear to me, but yes, this is what we present. I mean, the capture, transport, and storage, the full chain in our case, in pilot strategy project.
Yeah, and also, what about yeah, that was the second question, and then there's another one. Do you plan or need any exploratory wells prior to injection? And the second question, do you need a 3D reference survey for reservoir monitoring?
Yeah.
Well, sorry, please, Nikos, if you want.
No, it's for you.
Okay, okay. Yes, I mean, a 3D survey, what I showed already on the CO2 storage cost, injection cost slide. So we believe that we have already, 2D lines, two data sets. I think when you identify, the prospects, the prospective, the formations, then it's more cost effective to do it more dense at that point of the spot that you want to drill. So compared to having a 3D survey. So, but yeah, I think it's 2D survey, seismic survey will be more cost effective than a 3D. And for the exploratory wells, yes, I mean that's the next step.
Okay, we have another question. What are the current pressure and temperature conditions for the target formations?
Well, we don't really have. Please, Nikos, correct me. But I think we don't have such evidence. The only two wells we have available, it's on the margins of the basins. So we are lacking all information from the depot center of the basin. So we have not yet. So these formations, Pedalophos and Eptachori, they have not yet been drilled. So
Yes.
we don't have any information about this yet.
Yeah, I agree. We only have some information from, let's say, many years ago from data from the oil industry, but not really for CO2 storage. So they are not adequate information, let's say, for this story. We know about porosity, permeability, not pressure and temperature for the time being.
Mhm.
Thank you. Okay, please, if you have any more questions, please submit them or you can raise your hand. There's one question that came up just now. Is there any risk assessment planned, for example, on drilling integrity and injectivity? In other projects, risk revealed to be very high, for example, in Sala project in Algeria and Sleipnir in Norway.
No, for the time being, there is no risk assessment work. This probably when we go with more injection wells and then we need to get more information to get the risk assessment study now.
Thank you. Please, if you have any other questions, please submit them on chat. I do invite anyone who might want to ask a question verbally. Don't be shy. Feel free to raise your hand, and we can address them. In the meantime, I'll also put a direct link on the chat to next week's webinar, which will be focusing on the Paris Basin in France. And a reminder that this webinar is being recorded. We will put a link over the next sort of 24 hours on the same event page of this webinar with a link to the recording for this webinar. So you can refer back to it as well if you need to. Any other questions from anyone? We'll give another few minutes for people to type them up if they have them. Okay, well, I give another minute or so. I'll share a final link with everyone, which is on the pilot strategy website. There's a section with explore the regions for each project. So if anyone is joining from any of the other regions, or anyone indeed is joining from Greece, there's information on here about each one of the pilot regions that are being explored in the project. And you can click on each one of the countries, and for each one we'll have a few materials in the different languages. So there's a general video description of the project, and there's a poster of the project, and there's also a document with frequently asked questions, which can be very useful to share as well with extended networks. So we have them available in Greek, and also for the other regions in Polish, French, Spanish, and Portuguese. If you want to get a lot of that information in English, it is available in the About the Project page on the website. I'll give one more minute if there's no other questions while we come in. Dimitris, Nikolaos, anything that you would like to add?
No. Thank you,
Okay.
Richard, for organizing this. Yes.
Thank you, Dimitris and Nikolaos, for your very interesting presentations and for asking the questions that have come in. The recording will include, but they'll also be available on the website, the email addresses for Nikolaos and Dimitris, so you can contact them if you want to follow up on any of the work being done in Greece. But for me, thank you very much for everyone who attended, and hopefully we'll see you next week for the next webinar. So thank you all, and thank you to the two presenters today. I wish everyone a good day.
Yes,
bye-bye.
Bye.